this meeting will be recorded. So today we do have an important agenda. It's basically about the ongoing effort of the OAM spec 0.22 working draft, and it's basically the upcoming release version of the OAM spec. And we've sent out a issue to describe the whole design. I already included the issue link in the documentation in the meeting notes. If you can check that. So in this meeting, I will try to go through the spec a little bit. I mean, go through the proposal a little bit, and any feedback and input are welcome because it's currently a open discussion and comment period, and we will try to finalize the spec before middle of this month, and then we can publish the new version of release as part of the formal release of the specification. So let me share screen and walk through a little bit. There we go. Yeah, I've already put all the components of the new release of OAM spec in this issue, so it's easier for everybody to check what is going on here. I will run very quick introduction about what is changing and what is kept. So in high level, we still have several concepts, including component, workload type, application, and trait. The application scope is still there, but I will mention it later because we do not have a specific design for it for now. So we may want to discuss whether we want to include this concept in next release, but we can add it back when we have the detailed design, of course. And the first concept is component, of course, and we'll tend to rename it to component definition in the new release for several reasons. Because it's basically a schematic concept. It's basically an object to carry schema and metadata of a component. It's not an instance component. So we call all these kinds of object definitions in the new release. And it's equivalent to component in previous release and the component schematic of the V1 Alpha 1 release. So they basically work in the same manner. The purpose is to combine all the schematic primitives of one of the component into same object. And that means in this object, there is no any instance level fields. For example, there will be no values for your component defined in this object. This is kind of different from the previous release as well as the component schematic because it is more like more like a mixed object for both schematic as well as values of the component. That's why if you look at this new object, it's more like a combination of both workload metadata as well as the component schematic. So the workload metadata is basically what we already have in workload definition. For example, what is the identifier for the workload in this component, and how to operate this workload. For example, whether it is replicable, it is revisionable, something like this. We have a separate issue to discuss that maybe we want to put these characteristics as labels of this component, which will be easier for the implementation, because you can see here the characteristics are more like labels, right? But we are also okay, and we are also open to put them at field, so it's more like a structured way. But we need to note that we are open for community to add more field in this characteristic section, whether it's labels or not.
They're more like annotations, but okay.
So a quick question, like you see target user is like component provider or software distributor. So if we map to the OAM like 3 different roles, so they are more like infrastructure operator, So like, how do we like classify this target users?
So yes, the component definition are actually the previous object like component and component schematic, they are all expected to be authored by software distributor or component author. In earliest release, we mentioned they are developer, but this is not accurate. The developer actually only write code. He or another person can define his code into a component and install the component definition into your system. So that is this kind of role, which is very normal in a software delivery pipeline. Again,
Yeah.
this person can be developer or can be a DevOps, but essentially they are a component provider to the system.
I see. So they are not like infrastructure operator. They are either like application operator or developer.
Yes, they are not infrastructure operator.
Okay, thank you.
Okay, so for the workload characteristic for the workload metadata, we also have another field which is also exists today in the workload definition, which name is child resource. So this is useful when your workload is an abstraction workload. So it will generate some kind of existing workload types of Kubernetes. And then, for example, if you want to implement a trait, it need to have the way to understand, okay, what is the underlying resource? That is what child resource is used for today. And we will still have this field in this workload metadata. But in the latest implementation, we do not use this field because we do not have any abstraction workload for now. And we may, I think the direction is we do not want to advocate the abstraction workload, but of course we are open for other people to implement their own, but in the own spec, we will not advocate the abstraction workload because it is not very valuable as part of a spec. For example, the containerized workload, we will keep its schema, of course, but we do not advocate the way how to implement it. So this is part of the workload metadata. And right now, all of these data are in workload definition. So we merge them into the component definition. We do that because in most cases, workload definition, it just used by system. It's not authored by people. So we merge this, but those metadata has to be provided by somebody. So that's why we merged all of this metadata into this component definition, because essentially they are part of the definition description. In the implementation, we may want to, I think the direction we may want to go is to use this section to generate a workload definition. And the only purpose for workload definition is for the system to rely on as a discoverability of the certain workload types. But this section is open for discussion, of course, because it's more like implementation details. So this is a workload metadata. And the second section of the component definition is schematic of your or description of your component. And in the previous release, we actually introduced the way which is basically allow you to define a workload template and then parameters it support. We will still have this feature, of course. We just want to, the only change here is we just want to support many ways. So the first way is what we already have in OAM Kubernetes runtime. So you basically define a workload template. We may want to rename it to template. A workload template, it can be a full deployment, and then we define parameters for this template. So it's the same with the existing OAM runtime Kubernetes implementation. And we also want to support more component types. For example, in Kubevela, we experimented a bit the queue modules as a component, which works very well. So that means the component provider can write queue modules to encapsulate their resources. Like, for example, they can combine a service and the deployment together as a web service module, and they can define this module here. Similarly, we can support more types, for example, Helm, which is very widely used in Kubernetes world. So in that case, a component provider can just define an existing chart as a component, and they can use the same model to define the application to instantiate this chart. And also we can handle cloud services in similar approach. For example, you can have a ARM that is either ARM template. It's more like the CloudFormation in AWS. So you can define the ARM template in this section and define parameter here. So we can support more and more in the future, like CloudFormation, like Terraform. So it basically means that we want to define a standard interface in this section to enable people to bring more types of workload modules as a component. So this is the second section, which name is schematic. We also support what exists today, like Q and the Kubernetes raw resources, and we will also add Helm support in this section, and we will expect community contribute more, like ARM, like CloudFormation, like Terraform. So this is the second section, and the third section we call that parameters, but this is more like a optional field, because the purpose of this field is that it can carry a JSON schema of your parameters defined in above component schematic. For example, in this section, we basically define a template and parameters, but the parameters are defined in a spatial approach. In this section, we've actually tagged the fields as a parameter. And in this field, however, we will allow people to provide a standard JSON schema of the parameters in his components. So in that approach, the system will be able to use this JSON schema to render, for example, dashboard directly, or build their command line tool directly. Or at the same time, this part JSON schema will provide a straightforward way to let people know, okay, how what kind of parameters this component support, instead of reading the schematic section, which may be coupled with how you define how the component provider define this component. So this field is more like for clarity of the parameters supported in this component in a standard way. An equivalent approach is we have the parameter section in status. So in that case, the implementation will be responsible to generate this JSON schema based on the schematic provided in your component definition. So in that case, you don't need to define this field in spec. You just leave it to the implementation. So implementation will automatically update the status with a generated JSON schema so your system or user can use the JSON schema following the same approach. From my perspective, I will say the preferred way is to use Kubernetes generate the JSON schema for you. But in some other implementations, for example, Microsoft hope to implement component concept in non-Kubernetes environment. So then we need to find a way to provide the parameters and define it as a part of spec, because the non-Kubernetes implementation does not have status field. They don't even have a control loop. So this is the high-level design of the component definition. I don't know if you have any idea or any other feedback on this part. If not, I will go to the next section.
So how do I provide parameters for a workload? So my developer creates the workload, but there are things that are tunable in that workload, or there are items that are deployment specific inside the workload that, you know, I need values for. How do I provide parameters there?
You mean provide values for parameters, or?
Well, so I don't have a place now. So you're making a workload it's hard coded. I can't provide, you know, something that I might want to change inside of a workload. I have no way. So if I develop something and I say, oh, well, you know, I made it look like this, but I don't know what's going to happen when it's inside of your environment, you can change this particular item to be what you need it to be to work in your environment.
Right. A use case for us is, we want to override the image name when we instantiate one of these component definitions.
That is the purpose for parameters in every schematic. For example, what you have,
Right,
what you
but-
can do, right? Go
But
ahead.
that's not how, where are the parameters inside the workload?
What do you mean the parameter inside of the workload? You mean entry point thing?
So I'll give a very specific example. In medical imaging, we have something called a application entity title. That is actually, kind of it has to be inside of my network, a unique name for a service. If I give this, say I want to instantiate 10 copies of the workload, once the first one will spin up perfectly fine. As soon as number 2 spins up, there'll be a conflict and they'll both crash. I need to, when I spin up the second instance of that workload, I need to change that name so that it becomes unique in my environment. How do I do that? It's defined in the workload. It's not defined in the deployment. It's part of the development. But I need to be able to make that editable.
That in that case, you can define name of your workload as a parameter. No.
But I need to basically make a brand new workload every time I want to instantiate a new instance of it. Why can't I just have a parameter to be able to change? Because it's the only thing. So say I have, 10 million lines of code and I only have to change one value in the entire thing. Well, why do I need to rewrite a new component definition every single time just to change that one value?
Let's try to agree on the terminology. By workload, what is workload in your in terms of like OAM? Currently, the workload. Are you talking about workload definition, or you are talking about the real Kubernetes or whatever resource you emit?
So the workload is, say, the container itself.
Okay,
so the container has code running inside of it.
Yes.
I need to change something. I can't just spin up that container multiple times in my environment.
So
I need to make a small change inside the container. So I need to tell the container when you start change, I need to tell you change this one value when the next instance spins up.
So sounds like you just parameterize whatever thing you want to change. Is that not enough?
Right, but where do I list that as a parameter?
I don't think you don't want to. I don't think you want to define them as parameter, because from any instance, OAM is a deployment model. So what we are talking about is basically runtime behavior. So for example, in Alibaba, we have a project which name is clone set. It's a controller to control every pod.
Maybe that's how but you break, now that you've taken that away, that's how we were working in.
We're not breaking. So look at this, in the old way, the 0.2.1 way, there's a parameters. We still have this parameter. Lei, can you?
But you're only allowing that to be applied at the schematic.
That's where it's declared.
No, it's a declared parameters. You are going to apply that at runtime at the application level. Just like the previous one, there's no difference there.
Yeah,
Can you scroll down to the app? Scroll down to the app real quick and show us where the parameter is provided, not declared.
So here, when the cursor here is, this is where the parameters are declared, not the values are not set here. The values are set when you create the application, exactly like what we.
Right, so I can declare a parameter inside a workload here.
Definition. So schematic, right? In the schematic part, you declare the parameters. When you instantiate the workload, like that's the instance, that's where you provide the parameter values. I don't know if that's is that what?
Right, I understand that. I guess I'm just making sure that.
Yeah. You can totally do that. It's still there's nothing changed there.
Maybe the issue here is the application, the application example that appear in the issue, because maybe it's complicated. Maybe the sample is not clear, in my opinion, because
Maybe let Lei finish because I'm not sure if he has touched that part yet.
yeah, no, but I think that if I understood correctly, this is the definition, and the instance of the components is defined in the application.
Yeah,
is correct.
Yeah. Yes.
But the problem is that the application that is in the sample application that appear in this issue is not clear, in my opinion, because the parameter is very related with the information. Is related with the image and the command, and is not typical parameter that you include in this type of component, in my opinion.
Yeah, you could. Well, you're more than welcome to comment on this issue.
Yeah, I think. Yes, absolutely. I think that maybe we need to search a basic example with an application with 2 components and try to put a full example that what is the files that we are going to create to create this to deploy this application. Maybe it can be more clear.
Yeah, definitely. Yeah, we have plenty of examples. We're just going to add to this issue to make it more concrete. Yeah.
Right. So let me just continue the discussion on the other objects so you can have a full picture. Okay. Right. So we just finished talking about the component definition and the goal to support that we can leverage multiple types of components in the system. And for the workload definition, basically, I just mentioned it's basically used for the system to discover what workload types are available in your system. So nothing changed for the workload definition here. The only difference is that workload definition will not need to carry any other workload metadata because they are merged into component definition, which are makes more sense to me because workload definition is kind of split a lot of information into which are actually belonging to a component. So in that sense, we're also open to remove this object from spec because this object basically has only one purpose in the implementation, that is for workload types discovery. But we're okay to keep that in the spec. But you can see here, there's basically nothing important defined in this spec of this workload definition, just its definition rate, like today. So the next object is application, which was known as application configuration before. And there are basically no big difference comparing to existing application configuration. For example, you still need to define multiple components in the application. And for every component, you need to give it a name. So this is the name of the component instance. And then another parameter, another field is type. So this is the component definition, which you will use to instantiate this component instance. And then the settings of the component is basically equivalent to the parameter values we have today. So any field here, like image, like command, right? They are all parameters defined in your component definition. That means, for example, in this case, you will have 2 parameters. The first is command, the second is image. And then the application will be responsible for provide the parameters values to your component and instantiate it. But there is small change here that all the instance level values will be declared in application. So we do not declare any instance level values in component definition. That means in this section, this deployment should be a pure template. If you want to have a field which can be defined in application, you need to make it a template and give it a parameter. So this is how the application object works. And for traits, there's nothing changed compared to existing model or existing spec. You use a name to reference the trait definition, and you set the properties of the trait. And for trait definition,
Hold on,
no,
shouldn't, are you using settings and properties for the same exact thing in this one file?
You mean for this part we change it to properties, right?
Well, I don't care what you pick necessarily, but it seems weird that there are two different things.
So the only thing, yeah, they are basically doing the same thing, but we use settings here because it's basically workload settings in previous OAM spec. So we use the same name here as settings, but yeah, we can change it to properties. But I don't think very big difference here. I don't know from your perspective if it's change or not.
I just, again, from my perspective, it's you're taking what used to be defined up in component, and now you're moving it down to application.
Exactly.
And so therefore, everything in a component definition is technically a parameter. And so now I guess the problem I have is that somebody who's writing the application config needs to know more about what was developed than they did before. In the past, I could just give some, like under the hood, they didn't need to know how many GPUs or how much RAM or all this stuff. That kind of could just happen. And the application user could just know things that are actually deal with the physical application that they would understand. They don't understand, certain things that, a developer might care about, like environmental parameters or things like that. They just know, oh, this application does X and I need to, set these couple of things. The rest of this, they're going to have to go back to the developer and figure out what needs to be set.
You could still have default values in your template. Nothing changed here.
Right, but yes, you have default values in your template.
Yes.
I'm just.
There's nothing changed actually, because in previous spec, you define a component, right? That component is actually a template. So then you define overridable parameters. And those overridable parameters will be overridden by parameter values here. So in this section, they are overridable parameters.
But I also don't have how do I know the difference between a parameter? So in the past, I had this idea where I had a default value, and if it wasn't set, I knew what it would be. Again, you have to basically give this schema to the person. In the past, I only had to show them the parameters and say whether. Now I almost have to show them the whole schema.
No, you still show them parameters. There's parameter section here. So this section is exactly same with what you have in component today. Nothing changed. You show them parameters, that's all. I can give you an example. So right now in OAM spec, for example, let's go to the existing release, which is 021, and let's see a component here, right? Okay, so this is a component. So this section can be directly copied to the new spec like this section. Okay, so that's his new version. We just change this to a template, which is make more sense to me. So you still have parameters, you still have template, and you show them templates, that's all. Did I explain this more easier?
Yeah, and then I guess then what does the top of that become? So yeah, okay.
You mean this part is confusing?
No. Okay, I
Okay.
get this.
Yeah, nothing changed. And the parameters is image name and the catch secret. This is what you can fill in application. So image name and secret something, right? The only difference here is we support multiple ways to do that. So in this section, it's a Kubernetes native way to define a template, right? And we also want to support queue, support Helm, support more types in the future. So this is an extension point.
For me, the confusion is the name settings in the application.
Yes, this is what we provide as settings.
Yeah,
Correct.
Because
So
I think
right.
that I believe it that the settings is another thing. It's not parameters. For me, it was basically the major misunderstanding.
Right, and I think that's the difference. Is now I see that settings is actually parameters, and so that works fine. But I guess then it's redundant, and maybe it's only redundant temporarily, but it's redundant to have in the top part of the component definition. I mean, I understand why the name has to be there, but then why would I put, in the spec?
You mean which name? This name? Component name?
Right, is technically the name the
That's
same
instance
as
name. This is the instance name. This is the component name. We do have these two fields today in application configuration. So today, for this field, we call that component name, right? For this one, we call that instance name. So in that case,
but what about
mm-hmm.
so currently when you first, the spec above schematic?
You mean which one? You mean in component definition?
Yes. The spec above.
You mean for workload part?
So up here, right.
Yeah,
that kind of becomes redundant.
No, they're not redundant because the purpose is this one. So we need to have the way to define the metadata of the workload type. So I think you mean redundant is this one, right? But this one is also necessary for implementation because this one is a template. That means your implementation do not have a way to pass this section. For example, we cannot pass this section to know what's the real type of the workload. Even you write it here, but the implementation had no way to know because the template section basically have no structured schema in implementation. It's more like a string. It's a string here. So it's very hard for implementation to know what is defined in this string. That's why you have to explicitly to define what is the workload type in the workload metadata. Otherwise, your implementation will be really, really complicated. You need to read this section as a string and then somehow convert them to a structured object. I don't know whether I don't even know it's possible actually. And then you can know what to kind an API work for that. So this section, so actually all of this section, all of the fields in this section are for system to do something. For example, this section characteristics are for traits to check if they comply to this component, to this workload type. So this section is for implementation to know what's the real resource of this component. And this section is for, again, for system to know, okay, what is the real workload type of this component. That's why these things actually also exist today in the existing spec. There can be the way that we move the metadata section of workload into workload definition. It is true, we can do that. But in that case, we basically split metadata into two objects, which means the user, the author of component provider, will always have to need to define two objects to register a component.
Well, the
I'm
opposite
sorry.
argument. The opposite argument is if you have many component definitions that are very similar.
They can. You mean
you
they
won't
can
have- you won't
reference
have
the
to-
same
you-
workload type, right?
You won't have to duplicate the workload definition.
The
They'll
workload
be similar.
definition.
I'm sorry, go ahead.
I mean, yeah, I think another way to do it like this: workload type, right? And then we reference example deployment apps, right? So, but the problem here is that for this section, it can be actually different, even for same workload types. It's very hard to control its behavior because even for a deployment workload type, it can be it can have different characteristics. So you basically need to have multiple workload types and a reference different one. So that's why I'm trying to define this workload metadata as a section and part of the component definition.
Yeah,
I'm sorry,
I think what I struggle with is that, if you come up with a trait implementation that declares that it works against a particular, I'm not sure the right word is, workload type, that won't work anymore, right? Because there's workload, because components definitions are going to be generated all the time, right? They're not delivered by the system. So, a trait can never say which component definitions it should work against, because there'll be new ones all the time. Right?
Correct.
Kevin, why is that the component definition will be different all the time?
Because they're delivered, they're added to the system by the component provider.
Oh yeah.
Right. So it's an unbounded set, right?
It kind of depends. Depends if you have this. So if you use this containerized workload, then you don't really need a different component every time. But yeah, if you are more specifically tied up to a specific deploy application, yes. Then for the trait, I see what you mean.
I'm just thinking in terms of validation. Can I apply this trait to this component in the app file? Is it legal or not? How do I decide?
So in current design, it will need to check the component definition to know that. So it will check this section to know whether it can be applied to this component. That is the current design.
Well,
And
the trait declares the trait declares the set of component definitions or workload definitions in the current model that it applies to, right?
So I will say it's a little bit different because the trait will not care about what's the workload type or like that. So the trait will declare whether it can apply to certain characteristics. For example, whether it can apply to replicable workload. So let's go to the trait definition. So my reason is that we don't do this. We do this. Replicable is true. So we do this.
And that
Name it.
what does that imply? Does that imply that
this trait can only apply to any component which has replicable is true characteristic?
I understand that's easy to say, and I'm trying to envision that, to the trait implementation, that should mean that there's a specific field under a spec somewhere, right?
Yeah, it's here. It's characteristics.
No, that's not what I mean. It means it's going to go and try and modify some Kubernetes field. So, whatever the underlying component is, it needs to have that thing, right?
Yeah, that is actually the replica field of the Kubernetes resource. Kubernetes resource have several special fields like status, like replicas. So that means this resource have a replica sub-resource defined in Kubernetes. That is the implementation side.
I think that maybe the issue here is that the workload definition is a placeholder only, because there is no more information in the workload definition.
Sorry, you mean what? You mean we need to define this metadata in workload definition?
Yes, I think that yes, I think that we need to include this information in the workload definition, because if then in this scenario, in this example, what is the difference that you put deployment or to put another name here? Because there is no more information.
I can get your point. That's why I mentioned that the workload definition, the only purpose of workload definition in today is actually for workload type discovery, because no more metadata there.
And if why does we include the information of the Kubernetes, of the QA, or everything in the workload definition, and the component is send parameters only in the to the workload definition. All the try the different. If you say, okay, for example, deployment, I think that is a good example. If we want to deploy a component in a deployment, maybe the information, the specific information of how we can deploy a deployment in Kubernetes maybe appears in the workload definition, not in the component definition.
Yeah, so basically, the only thing we want to move to workload definition is this part. So this part actually belonging to workload definition, and what we also need to change is the name. This name could not be a resource identifier. It should be something like, for example, server. So in that case, we have the new field like workload field server. So this will determine the workload characteristic of this component. We still need to have a definition ref here, because this is how the system know what is the underlying workload for this component. So
I'm queued up to challenge that as well. I don't think you have that right, but
yeah, you mean the definition ref should also be moved to workload definition?
No. Well, that's one thing at a time. I'm right now. I think that there's not one definition. You can't guarantee that a template's not going to generate multiple, what I'm going to call sort of top level resources, right? Especially in like the queue case, you can generate a deployment and a service. So is it a deployment? What do you declare here, deployment or service? And why one or the other? What if it declares sort of two, resources that are peers? Like
I didn't get it.
Okay, let me try again. So
okay,
you've talked often that down in a queue template, one of the things that's attractive about it is you can generate more than one resource, right?
Yes.
So what resource do you put up here in the definition on line 25? You put the first one, the second one, both of them?
25.
If you have a queue template that generates two resources.
Yes,
let's name them. Resource A and resource B.
Yes.
What resource A or B do you put on line 25?
Only the workload definition. For example, if the resource is a deployment and service, I only need to put deployment as a definition ref here, because
aren't you making an assumption that there's some kind of a parent-child relationship there?
Parent-child? No, it's
why
not.
Why is deployment more important than service?
Because the component behavior is actually described by the workload instance in it. Actually, that is how we define a runtime characteristic of the component.
And you're
That's why
saying
we
that nowhere in the future will there be, some component that what it does is generate two different resources that, that the existence of both is the defining characteristic of that component.
Right, component is not a resource generator.
Oh, that sounds like a lie, but.
So why do you want to component to generate non-workload resources?
Well, by opening the world up to these templates, you've lost control over what a component can generate.
But you still need to have define your workload, right? That's why we have workload section. If you do not have the way to define your workload section, that means that thing is maybe not a component at all. If we remove this section, for example, let's say you just define any template here, you can define anything, yes. Even in existing implementation, you can define a non-workload thing in existing component schematic, and nobody will stop you because the implementation do not care whether it's workload. But from my perspective, if there's no workload, which means there's no something runnable in your component, maybe we should not use component at all to describe that. For example, a network policy, it is not a runnable piece. Then I don't think it's right we define a network policy as a component. That is my thing.
No, we got examples all over the place in our world where config map is a component. So
okay, so
because that
so you're already trying to use component to define config map, correct?
Yep. And
Okay.
it was necessary to fit some of our applications into the OAM model to do that, right?
Right. We have this discussion in the spec design before, so we're trying to do not include this kind of concept in OAM spec, for example, config map and secret.
I can understand leaving secret out, but
okay, I got a good point here. So your suggestion is that we totally open up component, so you can basically define everything which compose your application as a component, correct?
yeah, from our perspective, yes, that is the way that we have most of our examples sort of built.
So I'm also open for that. So the question is, in that case, do we still have workload type for this component? The answer seems like no, right?
Well, I mean, I think we're sort of winding back to my sort of mental model, right, where there is some kind of a description of what a component type is, and then there can be multiple instances of that are then used in applications. So
what is the advantage the component model bring to you when you define a config map as a component? You can actually use config map directly, right?
we could use a config map directly, yes, but we're trying to keep everybody in the OAM world. We didn't just want them having a loose config map YAML file laying around.
I see. Yes, in previous discussion, we actually talked about this. And the conclusion is that we found that people, the provider of config map is actually not part of the application because config map is defined by somewhere, is by somebody else. And your application is actually a consumer of this config map. That's what we observed in the community. So the application only cares about how to mount, for example, a config into the application. So the declarer, the claim of the config map is always provided by somebody else. For example, by another component, maybe it will generate a config map and then to let other to consume, or it's totally is not in scope of application lifecycle. Is provided by another system. That is what we observed before.
I mean, I can see your point. I can also see mine.
But how you can share configuration between different components in an application if you don't use a config map?
You mean?
Because imagine that you need to share configuration information between two components. In the OAM specification, you need to put the same value in two components. That if you have one, it's okay, but if you have 20, it's very complicated. For the reason you need to use a config map. I think that is that is the use case.
Yeah, in previous implementation, we have a special trait, which name is, I think, trait injector. It's basically a service binding trait. So it will actually declare what kind of data a component can provide and what kind of data can be consumed by another component. And yeah, I think it is approach to manage the config map and the secret. So the point here is that config map and secret is not something that we declare as part of application. It's more like a medium that we convey data.
Because, for example, if you create a component of MySQL, part of the application is the admin user, and this admin user is a secret. And you are not able to put this secret in the application configuration directly. You need to create a secret, and for the reason I think that the secret is part of the application. It's not something that you need to provide.
Yeah, that is a good point. So I'll show you the current way we do that. For example, you have application, and this application actually needs config map, right? So it's very interesting because the config map is not even belonging to a specific component. It's actually a global thing. But for example, if you have thing like this, so config map are in most cases and the secret in most cases are application level things. So essentially, if you want to model config map and secret in OAM, you basically need to define it here. It's not part of in most cases, it's not part of the component at all.
Yeah, but absolutely, but you need to create the part of the component is the requirement of the reference to the secret.
And then the secret, and for the component, you can just use the value from to consume the, for example, the name is myconfig. And that means the other component, which maybe in MySQL, it will actually inject data into this myconfig. So this is how we do this today. I mean, our own implementation.
So I guess what you are saying is that like for stuff like config map, basically it's the implementation like to design for that platform is going to use that service. While like it's something to service the application level.
Yes, you can actually use, for example, different type for this config map. For example, you can use either maybe SSO or I don't know what's Vault maybe. So you can use cloud service as your medium to transfer data. That's why for now it's not a component. It can also be a Kubernetes config map actually. So it's totally different thing from the existing model. That is actually the previous discussion when we designed the spec. We decide to not include config map and secret as part of the model.
Currently, we are trying to resolve this with traits. That is our solution on this moment.
You mean what's your solution right now?
Traits, using traits for
traits.
Yeah.
Okay, so you have the traits to manage the config map and secret, right? Yeah, that is a preferred way, at least in previous spec.
Yeah.
So right now the conclusion is that component is still a runnable unit. It's not everything is a component, but we're still open for that. So Kevin, if you have any thoughts, please leave comment in the existing issue. We can see whether we need some change or we can keep the existing assumption.
Okay.
Yep.
But again, we do not want to stop anyone to explore the possibilities. Actually, in Microsoft internal, they have they have a POC that they define a subscription of message as a component. So yes, it works, but just very strange.
Sorry, I have an unrelated question. So basically, I can see that like CO22 is available for public review. So like if there's any feedback, like what's the right channel like to provide the feedback? Is that the GitLab GitHub issue that you showing, or like is there any other channel?
For discussion, we can continue in the Gitter. We have a Gitter channel, right? And if you have any idea, just leave comment in the issue.
I see. Okay, thank you.
Sure. Okay, let's go back to the existing working draft. We almost finished the introduction, so we talk about traits. We also talk about the component. I think the most discussions may happen around the component part, because that is basically where changing happens. So I can see the main discussion is what's the relationship of component definition and workload type. That means this section. Where should we put this section? Ideally, especially this section, it's part of the workload definition. So this part is open for discussion. So if anyone have idea on that, we are happy to know what's your design regarding to this relationship. And for schematic, it's basically no change. We just want to support more types. So basically no change.
So I have questions about that too. Like,
okay,
is every platform going to be required to support ARM templates?
No, that's why it's just multiple options for you to choose. You can choose whatever you want.
Right, but you're baking that in as a first class part of the spec, not as an extension point. Which
this is an extension point. It's not a required spec. All of them are optional field.
So everything under schematic is like a raw type?
It's not raw type. The section here is raw type. This section is raw type. This section is raw type. The supported module type will be field. But I think you mean
somebody can show up with an OAM compliant, component definition that my platform won't support.
Yeah, they can
even though it's OAM compliant.
Yeah, so we have a rule, very strict rule, that what you need to implement or not. I don't think that makes sense in OAM. For example, I want to have my own way to implement a component module. You can do that. We don't want to enforce that you must have Q or you must have Helm. That's not our goal. But we can't make this whole section a role extension field. That's impossible, because we need to figure out which type you are using, right?
Right, but you're going to have to basically create something that says an OAM compliant platform is required to do, X, and then these are options. So, you're going to have to kind of come up with a way in the spec to basically, I mean, today you do it with, standard or other things. And so part of those schematics are going to have to be standard. I mean, you're going to have different component definitions. Then you're going to have a spec component definition, a standard component definition. I would think you'd have to do something like that.
So my perspective, we don't want to do that. We don't want to do that. I mean, introduce something like a standard spec. We don't want to define that. The community can do what they want regarding to
right. But then how do you claim capabilities as a platform? You're going to have a defined set of minimum. So is the minimum, if I just support ARM, am I compliant? Or do I have to at least support,
There's no requirement.
Right. So then I could say if there's no requirement, I don't support any.
You can support any, yes. Because
No, I
it's a
don't
component.
support any, but I'm still OAM
That's
compliant.
fine. Yeah, that's fine. Because
No, I'm
component
just
is
throwing it
provided
out
by
there.
somebody. The component is always provided by somebody else. If you provide a component described by Q, that's fine. If you provide a component provided, if your component provided, if you're
No, but
if you provide a
if there's
component provided by
nothing
him, it's also
required,
fine.
I'm going to create my own schematic.
That's also fine, because as long as you support component definition, you can, the schematic part is totally open for you. The whole system still works.
Not really, because how do I know what the schematic is? If
The
the
schematic
schematic
is
is John's schematic,
The
how do I
schematic is
know
here.
how to?
The
how do I
parameter
know how to-
value is a JSON. The parameter schema is a JSON schema. It's either defined by you or generated by system. This is the only thing the system need to know. So regarding to how you define the template, how you define the parameters, is totally, the system do not care. That's why we have this field. So this is the standard way to define your parameter schema. You can do that in here manually. You can rely on system to generate that.
But you're making so many assumptions there. Let's say that I want the system to generate my parameters, that
Yeah.
parameters down there. That assumes that the system understands the schematic type that,
Yes,
that I want
exactly.
to use. But,
yes, exactly.
And how do I ask the system whether it does or not? You know,
That's why you need to rely on a implementation to make that feature happen. And this feature can only happen in Kubernetes, actually.
I don't know which feature we're talking about that only works in Kubernetes now. It won't make the Microsoft guys happy, but.
Right, so for Microsoft side, I need to define this field for non-Kubernetes implementation. But this field, you either have this one or this one to clarify what's the JSON schema of your parameters. So in that case, you can bring in any kind of module you support as long as your implementation, I mean, your platform support. But that also means if you want to make the system support more types, you need to contribute a new supported type. That's why, again, we cannot define this kind of thing as a role extension. We need to clearly define what is supported right now. The system needs to know that.
Well, okay. You didn't define what supported it. Anyway, you're saying that what could be supported, not what is supported.
Yeah, so yeah, that is what could be supported in the system. There's no first class schematic module we can define. I don't know how that could be possible because none of this could work for any platform.
Well, I mean, in 221, there was a first class one that worked for, I guess, many people.
But only for Kubernetes, right?
Well, you're still expecting, as I understand it, that not all of these modules will generate a Kubernetes-like resource. Is that correct?
Exactly. So for ARM, it actually generates totally different thing.
Totally different thing.
Yeah, it's ARM. It's ARM ARM template. Totally different thing.
Going back to my previous objection, doesn't this definition file say it's going to generate a deployment resource?
So in that case, if you are using ARM, it's of course not deployment here.
So that goes back to my previous point.
Mm-hmm.
There's no relationship between what these schematics generate and that value there, none.
Why?
Because you just told me there wasn't.
If you are using ARM, then this place should be something runnable in ARM.
And if you're
right?
using Helm, it's going to generate 100 resources. Which one is?
No, if you are
No,
using
it
Helm,
can.
It can, yes, but you should define what is your workload in your 100 resource, right? Just like what you do here, you can define a deployment here, right? But you need to let the system know.
Well, there you can only
is
do
your
one. You
workload
can only do
type.
one thing, and that is and I understand that becomes your workload.
Actually
Right.
not, because for example, you have containerized workload. It will generate 2 resources for you, a deployment and a service. How the system know that?
My workload is a containerized workload in that case. The fact that it has different children is a different thing.
That's why we have the workaround, which name is child resource.
That I understand. I understand that a template used to generate one thing, like a containerized workload.
Yeah, so you're suggesting that we keep child resource but remove this section. That should work.
I don't have.
Yeah, you can see here. There's no big difference. You should have the way to let the system know what is the workload, no matter what kind of module you are using here.
Right, but you're removing the containerized workload middle thing, right? Which used to be what we would key off to say, yeah, I support that. I know what it's going to do, but now it's not there anymore, right?
So the direction is that we want to make that part a implementation detail. So you can use a containerized workload to implement, for example, a wake service component, right? But you can totally open to use a Helm chart to define that, right? You can also use Q to define that. You can use whatever method which supported to define. That is what we want to achieve.
But all right, I apologize here. I don't want to derail, but if I have a trait that's going to work against something that's defined by a Helm chart,
it actually works.
It does work, but I don't know how to implement the trait because I don't know which resource it's possibly going to generate that I might want to tweak.
That's why we need a workload definition to let the system know what kind of resource it will generate.
But it generates more than one.
And the trait will know that there will be, for example, let's say Helm, right? The trait will know, okay, this Helm chart will generate a deployment.
What if it generates 2?
Field. If your Helm chart can generate 2, you need to define which one is your workload.
And how do we tell the trait which one the workload is?
Sorry, what?
How does the trait know which one the workload is when it?
The component provider should define it. I know your argument is that, okay, your component can now package 2 workload. That is totally possible, but I don't think that is the normal case for a component to generate two totally different types workload. This is very rare. The only thing I saw this is in AI workload. For example, Kubeflow, the Kube job, it will actually generate 2 workload. One is for worker and one is for parameter in AI workload. It's really rare, but in that case, you still need to define, okay, what is your workload type? I mean, what is your workload definition for that? I think your argument will be, okay, maybe we should allow multiple workload in this case, but how can a trait work with multiple workload, right? You still need to define what is your workload definition here. Unless we have a trait which can work with multiple workload definitions. We don't have this trait. We don't have this kind of trait for now. And this won't change the fact that you still need to have define a workload identifier for what is inside your component.
Yeah, but I think the difference is that I would say that my trait worked against some kind of a workload definition.
Yeah, that is another thing we have already talked about. So
if that declares that it happens to generate 2 resources, then I would expect that trait understood that was going to happen. But
exactly, that's why we need to tell the trait what is the workload inside this component.
Yeah, I don't think we're disagreeing there. I'm just saying that again, a trait is going to, in our case, we have many controller-based traits, right?
Yes.
They're not template or template-based traits, which I think is also something we need to discuss. But they need to be coded to work against a fixed set of expectations. And if all the expectations are declared per component definition, then it's not a bounded set and it won't work. It goes back to that argument. Right? And you addressed that before by saying that, well, what you're really going to say is that a trait is going to work against replicable or pod specable or revisionable.
Yes. Should that solve your problem?
Well, I don't know. Is that a fixed set? Is that are those? Does the spec define what those are, or
yes, it's part of the spec. The spec will define. Actually, we have this in V1 Alpha 1 spec. We have server, skeleton. This is actually what we have for workload characteristics.
So if I have a trait that needs to be driven by some other characteristic that's not one of those three, I'm out of luck. I can't do that, right?
Exactly. So you need
that's bad, right? Because as new potentially new workload types show up,
I will say it's new. That's actually the main difference here. So I'm proposing we decouple workload characteristic from workload type. So the trait only need to care about the characteristics of the workload. You don't need to care about workload type, because in that case, you need to define a lot of workload types.
Right, but I'm saying that you can't know a priori the list of characteristics that might be important to a trait.
The traits only need to check whether the match applies to field of these characteristics.
I understand, but let's say 222, that the version 022, is in the field for 5 years. You can tell me that you're going to be able to predict all the characteristics required by any trait over that 5-year period? I don't think so.
But if we go into this characteristics way, they are basically becoming something like labels. You can add your own.
So I asked if they were extensible. You said no.
No, they are extensible, and I even write down it here. It's extensible.
Okay.
Right, it's totally extensible. That's why we propose to use characteristics instead. But I can totally understand your point. We can actually still use workload type to describe these characteristics, right? But in that case, every combination of these characteristics, we need to define workload type for them. Am I correct?
Well, I'm trying to figure out, what is the interface against which a trait implementation operates?
Yeah, so the current proposal is that we use this kind of label thing as the interface, not workload type. This is the current proposal. But yeah,
your objection that you might need multiple permutations is I think a good thing, right? A trait needs to be able to check something to say, can I operate against this thing?
Yes, exactly.
And if there needs to be 2 permutations because a trait can operate on this type of thing, but not that type of thing, then that's the way it's supposed to work, right?
Yes, we should have this feature. So what we are proposing is just we use different way. We use a label-based structure to express that, because the combination of the different labels, they can be very complicated.
Yeah, I mean, I understand the need for flexibility versus consistency.
Yes, exactly. We want to have some flexibility here instead of just keeping define new workload types. That is really, really complicated in a real production environment.
Something feels off, but I can't put my finger on it.
Yeah, I think you can actually trying to follow up in the issue. I totally understand your point, because in the first version of OAM spec, we define actually 5 types of workloads. But nobody use that. Nobody use those workload types because they are too restricted. They always came up with the idea that cannot fall into those 5 workload types. So how can we handle that? That is the issue we have in previous version.
Yeah, I mean, I get it. And it's I guess something, you know, it's the OO part of my brain that's having trouble digesting, I think, and I don't know whether, you know, replicable implies that, you know, it really implies it's either a deployment, a stateful set, or you know,
yeah, that is also another thing we want to change, because the replicable should not be mapping to deployment or stateful set. You can map into it to anything.
But it's making a schema assertion about the resource that will be generated, right? We talked about that already. So
it should not have relationship with the resource generated of the component.
It's setting an expectation. So I have a trait. It only works on things that are replicable is true, and that means that that trait can expect something, you know, some schema to be true, to be enforced.
Yes,
right?
yes, that is true. So for example, you can have the CRD, which can be defined as replicable as long as it supports the Kubernetes scale sub-resource.
Right.
That is the purpose we want to define these kind of things as a characteristic, because this characteristic can apply to a lot of workload types, including CRD, including your operator in Kubernetes. So in previous model, you have to define a lot of workload types, but how can you say all of these workload types are all replicable? We have no way to do that.
No, and I think that's a good thing. So I'm not.
Yeah, that's why we want to.
That.
Yeah, okay.
But
I know
it's
kind of different.
It's weird to say both.
Mm-hmm.
My workload is replicable and it's a deployment, right?
Yeah, we can't say that, and we don't want to say that.
Who's going to be checking that it's a deployment then? Who should be checking that it's a deployment?
The deployment thing will be defined as the workload definition or the identifier for the workload. That's why we have these 2 things. Those 2 things are decoupled.
For the workload.
They are decoupled. You can have a deployment, but it's not replicable. That can be totally possible because you don't want to scale that.
But who cares that it's a deployment in that case?
Who cares is for traits implementation. For example, you have a trait.
But you just said I shouldn't. If my trait is going to be messing with the replica,
so
it shouldn't be king of its deployment. It should be king of its if it's reference.
No. Your trait will always need to know what is the workload underlying, because for example, you mentioned you have a lot of traits, right? So every implementation of the trait will have to find out or have to operate on the underlying workload instance. So it need to have the way to know what is underlying kite.
So my trait shouldn't check the replicable characteristic. It should check.
It's all a different thing. Your trait don't need to care about the replicable thing, but it always need to care about what is the underlying deployment. You maybe want to do something else, not replica, not. For example, you want to add a label to it. Your trait just want to add a label to it, to the workload instance. How can you do that without knowing it's a deployment?
Well, I shouldn't. There should be a labelable characteristic.
But you still need to patch the label to the object, right? How can you fetch this object without knowing it's a deployment?
I'm just saying you're doing things 2 different ways to accomplish the same thing, right? You're saying the replicable characteristic is true, and that means that there's something in the replicas field in the schema, right?
Yes.
And then you're saying, well, but for labeling, you're going to make your assumptions based on the definition kind, right?
No, not for labeling. Actually, for everything, for every operation you want to do with a trait, you should know what is the underlying kite. That is only where you can list the resource from Kubernetes, because trait is an independent controller, right? I think that is also your implementation, right?
It's a
So,
it's a controller, yeah.
Yes, it's an independent controller. So how an independent controller know what is the target resource it's trying to operate?
Well, that's one of the things I'm trying to figure out with the spec.
Yes, if you check the existing implementation of OAM runtime, of OAM Kubernetes runtime, it's relying on a definition ref to know that. So this is a definition ref.
Yep, and you know, and normally containerized workload would have been, or containerized workload would have been used there, right?
But there can be more. You can have your own operators as a workload, right?
And we do.
We do. Totally different case. Yes, sure. That is what we want to solve.
And our traits say they work on containerized workload and, you know, Oracle workload X and Oracle workload Y.
Yes, I can understand what we are trying to do today, but I'm saying there are two purposes you claim that. So the first purpose you claim that is to say my trait work with a certain characteristic. And the second purpose is that you want to say my trait can only work with certain kinds. So right now it's coupled together. You can see that, right? So we're trying to.
It sounds like it always will be. It still will be, right? My trait can either decide to say that I work on anything replicable, or I work on these three kinds.
Okay, so if we go to this model, we are totally open for that. We just fall back to the original model. So we decouple. So we will couple characteristic with workload types. It totally works. It will just introduce a lot of workload types. So how we can actually go another model. We actually have this thing internally. So we basically have workload type, right? So you can your traits just apply to workload types, but we will need to define the workload characteristic as part of the workload type.
Workload character.
Yes.
Yes, and that was discussed on this call, moving that down, right?
So this section will be moved to workload type.
And then that raises your concern about workload type proliferation, right? Which
yes, we just in that case we will have a lot of workload type too. We actually have no way to fix the issue I mentioned in that model, I think, because the combination of these characteristics can be very different.
But I mean, but it is in fact a different workload type when you want to vary something.
I think you read the issue talk about the label, right? So in that case, I mentioned we support both. I'm not sure if you, yes. So in the original issue, what I'm proposing, we support both. So +2 actually is the way to determine how your traits apply to something else, right?
Yep, I did read.
It support both. It support characteristics and support workload types. That is the original proposal. Do you think that makes sense? No.
I believe I did when I read it before. I don't know whether these are ands or ors. I think that's a different issue, but.
So in implementation, it will check the rules one by one. It will check this first one and then go to the next one. If the first one fails, that means it cannot apply to that. That is the solution we proposed before. We support both.
So it's an and?
That should solve all the problem.
It does help, yeah.
And in spec, we still decouple characteristic with workload type. Right.
Right, but you know, at the same, diluting the value of workload definition to 0, so you can get rid of it, right?
Yeah. So the only value, the only value of workload definition is to discover the workload type. That's why I mentioned maybe we want to consider remove that from the spec if we want.
Okay, not okay as I agree. Okay, as I clearly need to provide my feedback in a different form. So
yeah, because in that sense, I think workload type is, in your case, for example, it can be considered as a characteristic of the component, right? So that's why it should work.
yes.
Okay. Again, feel open to write down all of the thoughts in the comment, and that is what we're trying to achieve, to get inputs from the community to see what we can release here. The only thing I just hope I can clarify the motivation behind this design. Yes, we want more flexibility in declaring the characteristics of your component. Okay, we're pretty much for today's meeting, and we do receive a lot of feedback from the community. It's really valuable. So it will be really appreciated if you can write down your thoughts on this issue, and then we can wrap all the idea together to see what's the final version of this spec working draft. Okay.
Yep, I think middle of the month is optimistic, but okay.
Yeah, we can set up separate meeting to discuss if anyone feel we need to discuss some details, so we can one-to-one meet to see to talk about more details. For example, how to support multiple component types in the system, how to claim the characteristics in a more flexible approach, right? Okay, this is pretty much we have for today's meeting. And so again, really thank you for all the feedback we have here, and see you next time. And if you have anything to want to discuss with maintainers, feel free to schedule a separate meeting. We are always there. If we are on Gitter, you can reach out to us through the email. Okay, thank you very much. Bye bye.
Okay, thank you.